Okay, so we're going into multiplying binomials, and this also is part of our explanation and discussion of quadratics. So we're going to first look at multiplying these binomials together. And we can find other information about this, but we want to first recognize how to do this. So there's that process that you may have heard of called FOIL, where you multiply the firsts of the two binomials. So x times x gets you x squared. So that's the F. It stands for first. So again, let me just write that so that you can recall. So F, which is firsts, is x times x, and that gives me x squared. Okay? And then we have the O, which stands for outside, and so outside is going to be the x multiplied by the 3, because they're on the outside of this problem. So that's x times 3 gets me 3x. And notice all I've done so far is I've just distributed this x to this term of the second binomial, and then I distributed it to the second term of the second binomial. So it just took care of that distribution. Now we have to distribute this term from the first binomial into both terms in the second one. All right, so let's go ahead and do that. So the next letter in FOIL is I, and it stands for inside. So the inside, we're taking the 2 and we're multiplying it by the first term of the next binomial. So we have 2 times x gives us 2x. And then the last letter is L, and L stands for last. And so we take the 2 and we multiply it by the 3. So we have 2 times 3 equals 6. All right, now that we have all of that, we can look to see what we've come up with. And you'll notice that we have the beginnings, or almost the completion, of a standard form quadratic equation. So I'm putting in here the appropriate signs according to the values that we discovered when we did our distributive process, because we need to have an expression that comes out of here. We also can combine the 3x and the 2x, because those are like terms, and we'll get a 5x, a positive 5x. So we have x squared plus 5x plus 6, and that all equals y. Okay, I'd like you to recognize that we have two different forms here now that we've written our equation in, but they both represent the exact same graph. This one here on the left is actually factored form, and you should be taking notes on all of this. So this is factored form, and this one is standard form, and we've talked about standard form plenty of times, but I just want to remind you that standard form is y equals ax squared plus bx plus c. Okay, so we have those forms, and previously we had learned the vertex form, which was y equals a times x minus h squared plus k, where a is the dilation and h comma k is the vertex. Okay, so all of these things should be in your notes because we're going to reference them regularly. Okay, so we've found, we started with a factored form this time. We started with a factored form and we converted it to a standard form. Okay, there's some information that we can gather out of the factored form that we can also gather out of the standard form, but we need to be able to go back and forth between the two. Okay, so our focus to begin with is going to be taking factored form and creating standard form, and then we're going to go backwards. Now we've already taken the standard form and created the vertex form out of it. And taking vertex form and creating standard form is very simple, but really doesn't give us very much. Other than we can then go from standard form into factored form. Okay, so I just said a whole bunch of stuff that eventually we will see come together, but I want to stick predominantly on the factored form because there's very important pieces of information that come out of this particular format. And so we're going to take a look at that in a little closer detail. Okay, so I want to focus on these two problems here. We have 12 times 0. And then we have 0 times 3x to the fourth plus 7x squared minus 2. So we have two different problems, but we should recognize that each one of them is going to yield a value of 0. Why is that? Because anything times 0 gets us 0. That's a very important concept to remember because we're going to use that concept with our factored form to come up with our values of x that actually will be our roots. Okay, so here we have the coordinate plane, and you'll notice that I have some points on my x-axis, and you should notice something that's consistent with each one of those points. So here's negative 3, 0, here's 1, 0, and here's 4, 0. So every time I put a point on my x-axis, I find that my y is always 0. And that's a very important point to recognize because recall that our factored form, these two factors here equal y. Well, we know along the x-axis y equals 0. So if y equals 0 along the x-axis, and our y is what these two factors equal, then we can actually find out what each of these two x's will be along this line because y is going to be equal to 0 on that axis. So let me write that out a little bit differently. So we know that from our form, our factored form, that y equals x plus 2 times x plus 3. Okay, and we know from the coordinate plane that on the x-axis y equals 0. Therefore, on our graph, where our graph crosses the x-axis, y equals 0. So instead of writing y, we can write 0. Okay, now that I've removed all that clutter, what does this tell us? Well, we have to recall what we discovered over here. Anytime you multiply something by 0, you get 0. So we ultimately want to find out what values of x will cause this whole equation to go to 0. So therefore, if we took this factor and made it actually equal to 0 and said 0 times x plus 3, that would all equal 0. Similarly, we could take this factor and make it equal to 0, and so we would have x plus 2 times 0, and that also is going to give us 0. Well, if we do that, we can easily figure out what a value of x is going to be because we're telling ourselves that x plus 2 has to equal 0. So what we're saying is x plus 2 equals 0. And so now we can figure out what x is. We simply subtract 2 from both sides and we have x equals negative 2. Similarly to the other factor, we have x plus 3 equals 0. And so we can subtract 3 from both sides and we get x equals negative 3. So let's just play with those numbers real quick. So we said x equals -2 and x equals -3. So we're going to take our equation again, x plus 2 times x plus 3, and we're going to first substitute a -2 into the equation. So we have y equals -2 plus 2 times -2 plus 3. So -2 plus 2 equals 0, times -2 plus 3 equals 1, and 0 times 1 equals 0. Therefore, we end up with y equals 0, which is what we wanted. So we can also substitute in the other value that we found. So y equals -3 plus 2 times -3 plus 3. So -3 plus 2 gives us a -1, times -3 plus 3 gives us a 0, and so again we have y equals 0, which is what we wanted. So both of those values of x give us a value that we want, and we can figure out where our graph crosses the x-axis. Okay, so here's the graph of this particular equation, y equals x plus 2 times x plus 3. And remember, we said that x equals -2 and -3, and sure enough, here our graph crosses the x-axis. Now, why is that so important? Well, because often in math, we're looking for the solutions to a graph. The solutions are the same thing as the roots, which are the same thing as the zeros, which are the same thing as the x-intercepts. All of these words mean the exact same thing. So by having the factored form, we're able to figure out where our graph crosses the x-axis. We're able to find the solutions, roots, zeros, x-intercepts, whatever you want to call it, but that's what we find right there. And we get that from the factored form. Okay, the other thing that we need to realize is that we have a vertex. As we always will, the vertex is at the lowest or highest point of the quadratic or the parabola, but we also know that the axis of symmetry cuts right in half, and it goes through that vertex. Well, guess what? The vertex is exactly halfway between the two solutions. It's between the -3 and the -2. So halfway between -3 and -2 is -2.5. So that is our axis of symmetry. So we can easily find that from this form, because we can simply cut the distance in half between those 2 points. So x equals -2.5, and now we can also find the vertex simply by taking -2.5 and substituting it back into our original equation, or into our factored form. So here I just took the factored form, and instead of putting x, I put the value of the axis of symmetry, because it is an x value at the point at the vertex. So when we solve this out, we'll end up finding out what y is equal to. So -2.5 plus 2 gives us a -0.5 for that factor. And then we have a -2.5 plus 3, which gives us a positive 0.5. And that altogether is going to give us a -0.25 for our y. So our y actually equals -1/4. And if we look at our graph very carefully, we'll notice that our vertex, which is right here, is about 1/4 the distance between 0 and -1, because it's -1/4. And so just from this equation, we are able to find the 2 points where the graph of the parabola crosses the x-axis by setting our factors equal to 0, and then we're able to look at the midpoint between those two factors to find our axis of symmetry. Since it's the x value of our vertex, we're now able to substitute that value into our x's to calculate what our y value is at the vertex. And we can confirm, and now we could graph this particular equation and make our parabola. So our final step here, just so that we solidify our information, is to say that our vertex is -2.5, -1/4.